Hello, this is Dr. Paul Cottrell, and I'm going to do another video today. This is October 20th, and I want to do something a little bit different here. Okay, so Dr. Roger Penrose, who was a Nobel Prize winner in 2020, is a physicist, and he has some unique perspectives, all right? Now, everyone's heard about the Big Bang and, the origins of like some sort of singularity that exploded and created this Big Bang, and there's this inflation and all this stuff, right? And when I was a kid, probably around age 13, 14, 15, I was interested in cosmology, and I was very interested in, physics and that kind of thing, right? I was decent with my mathematics, and um, and so I had a propensity to kind of like, was really interested in, how the universe start and quantum physics and all this kind of stuff. So and I, read some books, and I remember my parents subscribed to a magazine that was about the universe, and that's kind of one of those origins of, of intellectual pursuit. All right, so over the years, I've read certain books by Susskind and um, Brian Greene about string theory, also Michio Kaku. I met Michio Kaku actually in New York, but and also knew someone that was living in his building. He actually was living in a Trump building actually on the Upper West Side. But the whole point here, the whole point is that the universe has some complexity. And as a kid, I remember reading about it. I I never went into that field, obviously, but the thing is I think there's something to be learned about what Penrose is saying, because it's a little different than just the standard Big Bang. All right, what's the standard model? All right, what's the standard on what is the standard understanding of the Big Bang? All right. Well, pre-Big Bang theory, it was steady. It was like a steady state model where the universe just existed and it's not changing. Then people like Hawkins, and and others, started to realize that what there's this the Hubble constant and all this, that the universe is expanding, and that because of this universe is expanding, time can go positive and negative, and that you can roll back the time to a point. And this is where the whole Big Bang theory comes from. It was actually a joke that the universe was a Big Bang. It came from as a joke from a steady state theorist. But the point here is that the theory came out. It seemed to explain inflation. Now there's lots of other problems that take place between Newtonian physics, and the understanding of Einstein's gravity, and at the quantum level, them coming together at the singularity point. No one has been able to solve that problem. All right, so there's an incompleteness in Einstein's equations and quantum theory. They don't come together for some reason. All right, so Penrose has a different theory. Now, what's interesting about the Big Bang is that it starts from a point and it comes out. All right, but what Penrose is saying is that there's actually many Big Bangs, and that there's an infinite number of them. Now, there's a failed logic in Penrose I'll get to, but there had to have been a point. There had to have been a point of creation. There had to have been a point where this all starts, you know, right? It wasn't just forever in the past. It had to have been at some moment in time. Are we in the fourth, the 100th, the 10,000th Big Bang epoch, or what he calls an eon? We don't know. Are we in the second? Who knows? But there must have been a first. There had to have been a first. Now, he doesn't really dive into that side of it. But I'm going to apply Kabbalistic thought with what Penrose is saying. Now, you got to remember, what's the trajectory of cosmology in what's going on here? It started with steady state, and then it went to, because of the inflation, it went to this concept of the singularity starting at a point that exploded out. And then Penrose is taking it one step further. All right. Now, and I'll play a video that goes into detail of this, but Penrose's theory is this: it explodes out, and there is an entropy that starts to build up into the universe over a long period of time, and it gets disorganized to the point where you no longer have really complex matter. All right. Like, for example, at the singularity point, it was energy, but you didn't have electrons, neutrons, it's just plasma, right? It wasn't even protons, right? It was just energy. Right? And then it explodes out, and then over milliseconds, microseconds, and then, over a few seconds, then you started to see that the consolidation of that energy into matter, E equals mc squared, right? So, and then over time, through nuclearization with the star formations, heavier elements were produced, right? So it started with plasma, then you got the photon, and then you have these heavier particles that start to be formed that ends up eventually, producing carbon and nitrogen and gold and lead and all these, complex elements, all right? And there's a whole process, but it starts as pure energy, and over long periods of time, we have the heavy elements. But over time, because of the entropy of the universe, it'll eventually get to a point where there's what happens is things are spreading out, right? And and these black holes start to suck things up over time, and they get bigger and bigger. Now, maybe in the end, there's not one big black hole. Maybe there's a few black holes that are huge. But the point here is that energy is pushed out. There's a formation of matter, and then that matter becomes more complex, like us, and then eventually that will start to become dissipated. There will be an entropy, and that this matter is picked up through black holes, and then it's all sucked up. Now, maybe there's just a few black holes way out into trillions of years into the future, where all the matter is sucked up, and there's just one big black hole or a few big black holes. But what happens is that over time, this is part of the theory, over time, what will happen is that the temperature, remember, hot to cold, right? Temperature moves from hot to cold. So the black holes, all right, will eventually become hotter than the actual ambient temperature of the universe. And when that happens, this is that there's a radiation. This is the Hawking's radiation. And when that Hawking's radiation takes place, the black hole starts to kind of dissipate, right? And the whole universe starts to quiet down, right? And there's something called this, and I don't understand, I have to look this up, but there's a Hawking's point. that ends up happening. This Hawking's point ends up being the point for the next eon's expansion of the universe, the next Big Bang. So you have Big Bang, that's a Hawking's point, from the very end of a prior era or eon is what he calls it. A prior eon Hawking's point from a black hole that ends up being the actual Big Bang genesis for the next eon, only for this inflationary thing to happen, and an amalgamation of matter within black holes that ends up doing the Hawking's radiation, and then the Hawking point, and then eventually another eon that's created. And so there was these infinite number of eons that are happening. Now I see there are two problems with this. One, what happens if there's, I think he's right, all right? And I think it's coming to something that's very Kabbalistic. And that's why I'm doing this video, is it's a new thought that I have that will emerge with subsequent videos. The details of this thought will come out. Maybe I'll do 3 or 4 videos in this, but I want to, there's a Kabbalistic point, and what Penrose is saying seems to be matching up, all right? But Penrose, I think, has some, from my understanding what Penrose is saying, there's a couple holes that I'm not so sure that it's infinite. One of the holes about this infinity, this infinite perspective is that there has to be a starting point. Maybe it goes on forever. I don't think so. I don't think it goes on forever, but let's just say it does. But there had to have been a starting point. Now, in the Torah, it has the letters of the alphabet are Aleph, right? Bet, Gimel, Daled, right? So Aleph is not the first letter of the Torah. The first letter of the Torah is actually Bet, and it looks like a C with a base. Now the C with the base is as if someone's talking, all right? And then there's letters beyond it. The first word is Bereshit, or Bereshis. So this is, it's as if the first letter is speaking. Now the Aleph is known to be silent, so it wouldn't make sense to have the Aleph to be the first letter of the Torah. It makes more sense that the Bet is the first letter, because it seems as though it's speaking out words. Let there be, God said, and let there be, kind of thing. All right, so it seems to me that there is a silence, the Aleph, which also represents the upper level of this of Kabbalah, and the lower level of Kabbalah. Because a Yud, the Aleph looks like a Yud with a line with a Yud. The line represents the upper, between the upper and the lower world, the firmament. The Yud is 10. Another Yud is 10. So the Aleph is 1, but it's 1 through the composition of the division of 2 Yuds, an upper world and a lower world. And it's silent. So there's a world, and maybe it's 2 worlds. I'll explain that later. But there's 2 worlds, Atzilus and Bria, that do not have really that seem to be the Aleph. And beyond the Aleph is the unknown, the Ein Sof. All right. So you have the Ein Sof, and you have Atzilus, which is the next world, which is potentially the Yud, the upper Yud of the Aleph, and the lower Yud of the Aleph is Bria. And it's through this speaking where the vessels break. All of the of the attributes below Bria, which is the kind of the Yitzhara level, they all break, the vessels break with the ore. The ore is light. The ore goes into the vessel and they break. All right. And those ores break and then allows for Ocelus to exist. So Ocelus, the world that we live in. All right. Yitzhara, the world of kind of angels. And then Bria and Ocelus. Now, and then Or Ein Sof, the upper world that you can't get to. All right. It's there, but you can't see it. All right. You'll never be able, it's infinite and you can't get to it. So it seems to me that the bet in the first letter of the Torah is speaking out. It's the code, it's the mantra, it's the code of the universe. It's speaking it out. And these vessels are breaking. Now, doesn't that sound a lot like there was a cuff? There was a bet, not a cuff, but a bet that was speaking out some sort of energy that led to a expansion that leads to anthropic death and leads to a Hawking point that leads to another expansion. So the breaking of the ore breaking the vessel, the ore coming in and breaking the vessel. Now the question I have is do you have a universe when the Hawking point explodes? What happens? Because it's in an already inflated space, right? It's in an inflated space, but the Hawking point may not realize it is in an inflated space. So do you have an inflation within an inflation, kind of like a balloon within a balloon? Or do you have the Hawking point that actually explodes in an already inflated space? I have a feeling what happens is that point actually creates a new space. So you have an inflationary point. You have a point that does inflation, and then another point that creates a new inflation within it. So they're all embedded. And this is similar to what in Kabbalah, where you speak it, and the vessels broke, and the light went down to the next vessel, collected and broke. The light collected and broke. That sounds like what Penrose is saying. Now, according to Kabbalah, this only happened 6 times. All right, so maybe it's not forever. Now, if that Hawking point is what is the genesis of the next eon's Big Bang, is it possible, because maybe you might have potentially 5 Hawking points, because there's 5 big black holes, super black holes, not just one, that the total energy within the prior eon doesn't fully pass through to the next eon. If it's only one black hole, only one Hawking point, then all of the energy will go through. But what happens if it's not? Maybe there's 2, and only one of the Hawking points actually create. It is enough to be, it reaches a critical mass or critical energy level to create the next Big Bang. But there's the super black hole that's in the same eon with that Hawking point. And so not all of the energy of the prior eon is in that Hawking point. Therefore, you actually have a dissipation over time. So if you have trillions and trillions and trillions of years for an eon, and maybe each eon, as it's doing its new Big Bang, it's not all of the energy from the prior eon. And therefore, perhaps over time, it never, that last Big Bang, perhaps it never reaches that critical mass for the Hawking point. But I need to learn a little bit more about Hawking points, because I just learned about Hawking points a few days ago. But the point here is that I want to play this because it seems to me that it is very similaristic to the Kabbalistic breaking of the vessels. And this would be the Vav of the Tetragrammaton. Now, before I do that video, please go to my store, the-studio-reykjavik.com. I know this video is going to be a little bit esoteric. It's pushing the boundaries here of understanding. But please go to my store and help support my work. Get the collagen, peptides. This helps with bones, joints, your skin, your hair, your nails. Take this every day. It's a big scooper. You can mix it with food or with filtered water. Some people even mix it with milk. It has a great amino acid profile that's shown on the screen here. Take it every day to improve your skin, your hair, your nails, your bones, and your joints. It's a great product. And also get the resveratrol. Resveratrol is an antioxidant. It also helps to get rid of senescent cells. Our cells, when they stop dividing, they just sit there and collect garbage. So you want to get rid of those senescent cells. And in tissues that can regenerate, that have basal cells, that have stem cells, by getting rid of the senescent cells, you'll be able to repopulate your tissue, and it'll be younger, because age of tissue is based on telomere lengths. So please go to my store, the-studio-reykjavik.com, and get the resveratrol. Get rid of those senescent cells. It's an antioxidant, and it's synergistic with C60. This will help to slow down the aging process, and will help boost up your immune system and improve your mitochondrial health. So please go to my store and get the resveratrol. All right, so let's play this video. This is from Dr. or Professor Roger Penrose. He won the Nobel Prize in physics. He has a revolutionary thought here, right? And it's not so easy to understand, because this concept is also tied with twistor theory. All right, and twistor theory I'll talk about a little bit later, but I can't do it in this video.
In about a few billion years, scientists predict that our universe may face a catastrophic event known as the Big Crunch. This is when all matter, stars, galaxies, everything will start collapsing back into a dense state, leading to an intense, high-energy ending. But what if that's not the whole story? According to Professor Roger Penrose, our understanding of the universe's end may be far from complete. He proposes that in the distant future, another Big Bang could occur.
I've come to the view that there was something before the Big Bang, and it goes on expanding, and it's now indulging in this, what's called the exponential expansion, which is caused by what people call dark energy.
In other words, he argues that the Big Bang isn't a one-time event, but rather an optical illusion of sorts. The universe might go on forever, not in a repeating cycle of Big Bangs and Big Crunches, but in a continuous, unending sequence. He even boldly claims that this is the evidence of a previous universe, existing just before ours.
All right, so you saw those cones. Now, imagine those cones are the breaking of the vessels that are in Kabbalah. Now, assuming that the energy is going, all that energy is going into the next eon, then it wouldn't dissipate. But what if it's not? Because most likely there's going to be cases where you're going to have a Hawking point that reaches, a critical situation where it will create the next Big Bang. But you may have something that's almost a Hawking point in a supermassive black hole that has not merged with that other black hole, and therefore the energy is left in the old eon and not into the new eon. And therefore, eventually, you're going to have this dissipation of energy, for each eon. Eventually, it just dissipates. Now it gets to a certain point where the Hawking point can never be activated, and therefore the next Big Bang doesn't happen. And in Kabbalah, there is this concept that all life will stop. So there is these breaking of the vessels, and then we're living in this world, and eventually there is a rebirth, right? But eventually there will be nothing. There'll be life does not continue on. The universe does not continue on. That's Kabbalah, all right? But that's way, way super far into the future, all right? Not human future, like universe's future, what he calls eons. It could be 5 eons or 6 eons or whatever. Oh, wait. Maybe we're in the last eon. If we're in the last eon, it's still it's still trillions of years away from now. But the point here is that the universe dies. It does die out. It doesn't go on forever. And there was a point. So I think he's wrong about it being infinity, and I think I explained why. You have, at least Kabbalistically, you have the bet that's speaking out, creating the energy, right? The bet, that's the first Big Bang. And then subsequent Big Bangs are because of this anthropic principle with the Hawking point that he's talking about. And then I'm not sure if all the energy gets to the other side. I don't think it does. I think that there is a dissipation. All right. Now there's a Hebrew word called simpson. Simpson is this contraction. So light has to come into the vessel, create the vessel, and it's pulled out. I have to reference some Kabbalistic books to get to the details of this, but how I understand this is that a particular attribute of the Sephiros when it's being created, there is a light that comes in, and then and then it's contracted, comes out, and then there is this vessel, Kelm is created, and then it comes back in and kind of solidifies it. All right, but these Clem can break. All right, so there is, and when it's breaking, there's less of the Or Ein Sof in the subsequent vessel. So the energy force seems to be dissipating. Once it starts, I'm not sure if the energy, it looks like there is an energy source that's coming from GETTR into Chokhmah, all right, and that what that does is but it's contracted. There's a symptom, so it's allowed to exist, and Chokhmah and Bina, or Atzilus and Bria, those worlds were strong enough to hold the light, but the others in the attributes within Yitzhak could not, and they break. All right. And it seems to me that each one of as the light was going into these different Kelms, it gets more and more constricted to the point where we're in this world where there's just a little bit of that Or Ein Sof light, that just a little bit of that energy force in all matter in this world, in Asya. And in Asya, with that little energy force, that's where blessing and curse can come through. All right. But in subsequent worlds, the light gets more and more intense, because the lower worlds, the symptom contracts more and more with each of the attributes, because each world has 10 attributes. So when it's going through its attributes within its world, there's a light that's constricted. I think this is what's happening, is there's a light that's constricted. And that's why, so, all right, so when they did the kind of the radiation map of the universe for the origins of the Big Bang and was the universe lumpy or smooth, they found different points that seemed as though they had the signature of the Hawking point, and there were 5 of them. So it's not one gigantic, this is the reason why I'm saying it's not one gigantic black hole. There seems to be a few black holes at this moment in time that reach a certain critical mass to go over to the next side. But what happens if that 5, I believe there were 4 or 5 that were on the map that was detected. What if, for the Hawking point, what if there were really 10, but only 5 got through? That means half of the energy, assuming they were all roughly the same size, only half of the energy came through in this eon. So there's an Or Ein Sof that's being contracted. There's in each eon. All right, so that's the metaphysics of trying to map what Kabbalah is saying and what Penrose is saying.
Certainty.
The evidence for it is really quite strong. The strength of the signal we see is a 99.98% confidence level, which is pretty strong. A single black hole gradually swallows most of the cluster. All that energy bursts through onto the other side.
So what is the piece of evidence Professor Penrose is claiming? And what could it mean for the distant future of our universe? Back in 2019,
So you're already using ChatGPT, and well, that's awesome. There is one little problem. You're not making any money with it.
Back in 2019, Roger Penrose co-authored a research paper published in the Royal Astronomical Society titled Apparent Evidence of Hawking Points in the CMB Sky. In this paper, he and his team claimed to have found several anomalies, potential evidence of a universe that existed before our own. As stated in their research, each anomalous spot would have originated from a highly energetic point-like source, resulting from the Hawking radiation of supermassive black holes in a cosmic eon prior to our own. Simply put, these dark spots may represent actual evidence of a previous universe, or, as Penrose describes it, an eon rather than a universe. We covered this in detail in our previous video here. But just to recap, this idea falls under the framework of Conformal Cyclic Cosmology, or CCC. It replaces the traditional inflation model with a lambda-driven exponential expansion of a universe epoch, referred to as an eon. In this view, our universe is one in an endless sequence of eons, each starting with its own Big Bang. It's important to note that the lifespan of each eon could stretch up to a Google years. And if time truly extends infinitely, the idea is that another Big Bang would eventually occur. What remains in this remote future is the ultimate fate of black holes. Penrose suggests that some of these supermassive black holes from a previous universe might become bound to the conformally stretched Big Bang of the next eon. The observed anomalies are proposed as evidence of this connection. Here we have to make it very clear that these claims are highly controversial and not widely accepted within the cosmology community. But let's take a step back for a bit. How does one argue that these spots are definitive evidence of black holes from a prior universe? Well, it all circles back to a concept long proposed by the late Stephen Hawking.
Where I come in on this is that I think they're actually seeing the signature of the breaking of the vessels. I think they're seeing the actual signature of, because we're in our eon and we're looking at the map of our eon and the birth of our eon. That means that we saw the last vessel break that creates Asiya. Now the question is, can we peer into a prior eon, not just the Hawking point, but even beyond it? Who knows? I don't know. But the thing is that this is eerily similar to what Kabbalah is saying about what happened with the universe. So we'll see.
Hawking radiation. The whole point is pretty straightforward. We are able to observe dead black holes left behind by earlier eons. These black holes, possibly as massive as 10 to the 14 times the mass of our sun, would have evaporated through Hawking radiation. And so, in the grandest picture of this concept, these remnants would form what is referred to as a Hawking point. The so-called warm points, which are all about 8 times larger than the diameter of the moon. As Penrose stated in his paper, we must bear in mind that despite Hawking radiation being of an absurdly tiny temperature, over the eon's history, the entire mass energy of the whole will be finally radiated away. And, in the conformal picture, this will take place within what would effectively be a single Hawking point H. Since we know that the Hawking evaporation of a supermassive black hole would generally take much longer than the current age of our universe, some information from a previous eon may seep into the next cycle. If you're interested in the full details, we recommend reading the paper yourself. There's a link in the description below. But without delving into the nitty-gritty details of what he mentioned in the paper, he and his team identified several characteristics of these Hawking points as anomalies in the CMB map. Now, for the moment you've all been waiting for, where exactly is this evidence on the map? These are their galactic coordinates. And if we map these visually, here is where they appear.
According to the equations, what you find.
Yeah, I thought
is
there
that
were
these
4.
signals
There's
should
not 4. There's many. There's a lot more than that. Maybe, I don't know, maybe 20. Now, what is interesting is he said, remember what they said, 8 times the size of the moon, the Hawking point. They find out that actually the CMB showed that it was actually 4 times. Now, I think that from a Kabbalistic reason, I think what's happening is that you have the Hawking point, and when it explodes, if you look at like a supernova or a pulsar, I think a pulsar is a better example. There's some sort of spin that's taking place, and that the radiation is spinning out of its axis in the north and in the south pole. All right, so the energy that's coming. This is part of the reason why I think that each eon has a Simpson, a contraction. The point that Hawking point, I think, right? I got to learn more about it, but my gut feeling is this: is that the point explodes, but it doesn't explode. It's releasing energy in its pole, and the pole is in the north and the south. So based on its orientation. So that means that there's 2 worlds, there's 2 universes that are being created. All right. Now, what's interesting is in Kabbalah, it always talks about a lower world and an upper world. So what you might be seeing is the Simpson contraction that allows for a new eon to take place. I'll call it the positive eon, and then the negative eon, or the mirror eon. And so if it's 8 times the size, only half of that energy goes to the North Pole and half of that energy goes to the South Pole. So the 2 universes are exploding out. We only see our universe, our eon, while there's a negative eon, negative universe, or South Pole universe that we don't see because we're not part of that. And so you're seeing half of that energy that's coming from that point. Now, I suspect that because there's so many black holes, so many Hawking points that are taking place with this, that there are probably some black holes that haven't reached the Hawking point. That didn't reach that critical condition. And so it's in the previous eon, maybe waiting to consolidate and create. So it's possible that you have one eon that in time 1 creates one eon and it's negative. And in time 2 of the previous eon creates another eon and it's negative until it uses up all of its energy. But I'm just working this, you're seeing me I'm thinking about this as we're watching this. I haven't seen this video. I know a little bit about the CCC, but the thing is that there's a mapping of what Penrose is saying. Not everything that Penrose is right, but there's a big part of it that maps well with Kabbalah.
the dark matter in the next eon, and you should be able to see signals.
Although these signals aren't something we perceive in our daily lives, an analogy should be able to illustrate this. Think about when we're browsing or shopping online. Our data doesn't just stop there. It often leaves traces without us even realizing it. This information gets passed along to other merchants, platforms, eventually data brokers, where it can be bought and sold, even in places like the dark web. So it's similar to the signals Penrose described, that echoes from the past can persist into the future eons. But unlike those remnants, we actually have the power to manage our digital footprints. And that's why we're excited to partner with Incogni for this video. It's a service that helps users protect their personal data without the hassle of contacting each, all on this dashboard, so you can see exactly what's going on. Maybe even hundreds of lists where your email, phone, Incogni is on it. They sniff those sites out and get you off those lists too. Ideas. You'll get an exclusive 60% off their annual plan. Penrose.
You're a leader. You have a vision, but do you have visibility? With Smartsheet, you do. Smartsheet helps leaders inspire their teams to plan, execute, and scale work to deliver results faster.
Where's these commercials?
Smartsheet.
Ah, come on.
POV, you started small with chair workouts instead of the gym, and now you're more resilient and pain-free than the gym guys.
Penrose reiterates his belief in what he humorously calls a crazy theory of mine. He suggests that our universe will continue to expand until all matter decays, and then a new Big Bang will occur. But occasionally, remnants from a previous eon may seep into our current one. But does this theory fully explain our universe? The biggest difference in predictions between CCC and inflation theory lies in what we should expect to see. CCC suggests that we would find imprints of a universe before the Big Bang, visible in both the large-scale structure of our universe and in the CMB. On the other hand, inflation theory requires that any point where inflation ends and a hot Big Bang begins must be causally disconnected from other regions. To put it simply, each region of the universe should not show any interaction with another, the past, present, or future. Our universe's properties should be independent of any preceding universe. Observations from missions like COBE, WMAP, and more recently Planck have put very tight constraints on the existence of such structures. We see no evidence repeating patterns, concentric circles, or Hawking points in the universe. When the data is analyzed properly, the findings consistently support inflation and not CCC. Although Penrose has his supporters, the scientific consensus strongly disagrees with his conclusions. Many scientists have pointed out that his predictions are not supported by the data, and any claims of finding such effects seem to rely on what they argue is a flawed or unsound interpretation of the data. Despite that, Penrose continues to advocate for this CCC idea.
When I've had these various ideas, I could go on lecturing about this forever, because nobody will ever know whether it's right or not.
What's interesting is that while Penrose references theories by Stephen Hawking, Hawking himself had a different view. In his 2010 research paper, Hawking stated, "Our universe seems to be one of many, each with different laws." He believed in the hypothetical set of all universes, a perspective quite different from Penrose's cyclic cosmology. In his own words, our cosmic habitat, now the entire observable universe, is just one of many. Speaking of the multiverse and how it relates to CCC, as briefly mentioned earlier, each cycle of an eon lasts for about a Google years, a staggering number that is one followed by 100 zeros. So a Google years is 10 to the 100 years. After such a long period, a new eon begins, and this cycle continues endlessly. So one of the intriguing questions that arise is, if the universe continues on for eternity, would it eventually lead to another Big Bang? Or perhaps a big crunch? What are the consequences of such an endless cosmic cycle? In order to address this, we need to revisit a term known as the phase space volume. It's a theoretical space that represents all possible states that the universe can exist in. This volume is an astonishing 10 to the 10 to the 123rd cubic meters. It's so vast it defies conventional understanding of scale. Our current observable universe, that is, the part we can see with our telescopes and instruments, is around 10 to the 26 cubic meters in volume. While this might seem unimaginably large, it is still minuscule compared to the theoretical size of the phase space volume, even a Googleplex universe we talked about earlier. Now, just for the sake of argument, let's imagine a universe that extends a Googleplex meters across. If you were to traverse such a vast universe, you'd eventually start to notice something peculiar: repetitions. And not just any repetitions. I mean repetitions of yourself, an exact copy of you. The reason behind this repetition lies in the concept of quantum states. To put it simply, a quantum... Are your kids in grades 6 to 11? Harvard has made SAT and ACT score submission optional in its admissions process. If they don't require... To put it simply, a quantum state is a specific arrangement of particles and fields in a defined system. In the context of the human body, this means considering the unique arrangement of its atoms and particles, everything that makes us who we are. The total number of quantum states that describe the space we occupy is around 10 to the 10 to the 70th, assuming that we're roughly occupying about a cubic meter of space. If you're wondering where this number comes from, it is derived from the combinatorial possibilities of arranging particles under maximum entropy of a system, taking into account the limits set by the Heisenberg uncertainty principle. For example, when considering entropy in black hole thermodynamics, it was found by Stephen Hawking and Jacob Bekenstein that its entropy is proportional to the surface area of its event horizon. However, when considering ordinary volumes of space, the number of quantum states depends on the volume and the types of forces within it. And so, for a volume of 1 cubic meter of space, there are a finite but extremely large number of possible configurations. So now let's put this into perspective. If you occupy a space of roughly 1 cubic meter, and there are about 10 to the 10 to the 70th possible quantum states for that space, this means there are this many different possible versions of you in terms of atomic arrangements. It could be the atomic arrangement of you resembling famous celebrities, your favorite animal, or a complete arrangement of you without any atoms at all. The thing is, you could be anything. But despite those gigantic possibilities of what you could have been, that number is still far less than a Googleplex. So the basic idea is that if you were to travel a Googleplex distance away from yourself in this hypothetical universe, you'd eventually encounter another arrangement of atoms that exactly matches yours, another version of yourself with the same exact brain chemistry, the same thinking process, and the same behavior. And so, in a sufficiently vast Googleplex universe, repetition is not just possible, it is inevitable. If we live in a universe as vast as a Googleplex across, where space stretches on forever, then not only could there be another you out there, but there could also be endless variations of you and everything else. Perhaps you will be marrying your biggest crush. I mean, every possible arrangement of particles, every possible history, and every possible future would exist somewhere in this vast multiverse. Based on our current understanding of the universe, if we turn back the clock far enough, we encounter conditions of extreme density, temperature, and energy. Under these conditions, we approach what is known as a singularity, a point where the conventional laws of physics no longer hold. If the distance scales become too small, time scales too short, or energy levels too high, our current understanding of physics breaks down entirely. Now consider reversing the clock back approximately 13.8 billion years, right up to the hypothetical zero mark of the Big Bang. This point is known as the Planck era, exactly 10 to the minus 43 seconds after the Big Bang. This period from the Big Bang to the end of the Planck time is referred to as the Planck epoch, a realm beyond the reach of our current physics. So to grasp how incredibly short the Planck time is, let's imagine how many Planck times fit into just 1 second. Let's think of this in 2 ways. First, consider that the universe is nearly 14 billion years old. If we use this age as a single unit of time, a universe, then there are more Planck times in 1 second than there are seconds in 10 million trillion universes worth of time. Pretty mind-bending, right? Now let's look at it another way. Our galaxy, the Milky Way, contains roughly 100 billion stars. Then there are approximately 2 trillion galaxies in the observable universe, so each with about 100 billion stars. Now imagine that each star in the universe has 300 identical Earths orbiting it. I mean exactly identical Earth, just like ours. So here's the mind-boggling part. If you counted every grain of sand on each of these planets, around every star, in every one of the 2 trillion galaxies, you would begin to approach the number of Planck times in a single second. 1 grain of sand equates just how much a Planck time is in a second. It's astonishingly small. The Planck time can be thought of as the frame rate of our universe, while the Planck length represents its pixel density. According to our best understanding, during the Planck era, all 4 fundamental forces of nature were unified into a single superforce: gravity, the strong nuclear force, the weak nuclear force, and the electromagnetic force were one aspect of the same thing, much like how water can exist in different phases like ice, liquid, and gas. If this depiction of the universe is accurate, then we would expect a series of phase transitions to have occurred in the early universe. Initially, as the universe expanded, all possible particles and their corresponding antiparticles would have been created in great numbers. As it continued to cool, these particles would have annihilated each other, converting their mass into radiation. The process continued until approximately 308,000 years after the Big Bang, when the universe became cool enough for neutral and stable atoms to form without being immediately torn apart by high-energy photons.
The theory predicts that at very high energies, there should actually exist forms of matter which turn gravity on its head and cause gravity to behave repulsively instead of attractively. The inflationary theory is basically the hypothesis that this repulsive gravity was the bang of the Big Bang. It's what set the universe into this period of gigantic expansion.
About 55 years ago, this CMB radiation was first detected, which provided strong empirical evidence for the Big Bang theory. It went from being one of several possible models for the universe's origin to the leading and only one that fits the observational data. But still, the proponents of the steady-state model, such as Fred Hoyle, resisted this shift. Despite the accumulating evidence, they continued to propose increasingly far-fetched explanations. But over time, these contrarian views faded into obscurity as their claims were increasingly shown to be trivially incorrect, and eventually their research programs ended with their passing. Could we be witnessing a similar situation with Penrose's CCC? After all, finding patterns in the CMB data is something that requires thorough caution. The recent B-mode findings from the BICEP-2 experiment have sparked intense debate. This is a reminder that there is always a risk of interpreting patterns that are more reflective of our imaginations, the imagination of our algorithms, rather than genuine evidence. From the 1960s to the 2000s, cosmology developed at a quick pace with a strong focus on understanding the growth, evolution, and fate of the universe. There were observations that were no doubt true, but they also highlight areas where the Big Bang theory lacks predictive power. The theory itself does a great job explaining a lot, but there are still phenomena in the universe that it does not account for, which suggests that there may be unknown factors that are hidden from our current understanding and observations. So when faced with such mysteries that current theories can't explain, science generally offers 2 options. The first one is to devise new theoretical mechanisms to explain the phenomena, and secondly, to assume that the universe was simply born with the necessary properties for what we observe. As we all aware, only the first approach holds real scientific value. It is the path that scientists must take, even when it might not yield immediate results. After all, science is about following the evidence wherever it leads, and the universe itself will ultimately determine what is true and what is merely speculation.
Here in Manhattan, it's time to raise health with better access, better outcomes, person by person, block by block, with a powerful system of care that's made for everyone. Northwell is here, Manhattan, and we came to raise health.
So don't let that gem spoil your trip.
Is that a chip?
So that video talks a little bit about the CCC, and I'd like to just do a product placement here. Please get the probiotics that I have. I have a veggie cap version of probiotic, and I also have the powder version. Normally I take the powder version, I mix it with my food. You can mix it with water, right? Put it in a smoothie. But these probiotics are really important to get the proper gut biome that you need for proper digestion, to improve the mucosal lining in your gut. By improving your mucosal lining and improving your gut biome, you're going to be able to absorb energy better. You're going to have a better metabolism, better communication between your gut and your liver and your gut and your brain. You'll have higher mental acuity. You'll have better emotional mood. In addition, by maintaining that gut biome, you're going to reduce inflammation in the gut and reduce the chances of further gut disease, mutations that may lead to cancers or leaky gut syndrome. So please, it's really important to improve your gut biome. A lot of people don't realize skin problems can be due to poor gut. So please go to my store, the-studio-reykjavik.com. It's the-studio-reykjavik.com. The link is in the description of this video and all my videos, and get the probiotic. I also have vitamin C to help to boost up your immune system. It's also good for your skin. Take this every day. If you're not feeling well during the cold season, take a double dose of it. Make sure you drink it with filtered water. And lastly, I have a very strong antioxidant. It's called C60. And C60 is a molecule. It's 60 carbon. It's suspended in a lipid, in a oil. You can get it in MCT coconut oil. You can also get it in extra virgin olive oil or avocado oil. But you take a teaspoon of this a day. Soak up those free radicals, help to improve your mitochondrial health, so your ATP goes up. And over time, what you're going to notice is that you're slowing down the aging process. You're going to have more energy. And by having more energy, that means your endocrine system could get better. By having more energy, you're going to be moving around and have more muscle mass. You're going to be moving around and having better circulatory system. In addition, by having more ATP, you're increasing the chances, increasing the probability of improving your immune system. So please go to my store, the-studio-reykjavik.com, and get the C60. Boost up your health by soaking up those free radicals. A lot of people don't realize that free radicals do lots of damage to the cell, and if your cell is damaged, it's not going to perform well. So if you soak up those free radicals, your tissues are going to perform better, and your body will be in a better state. That's why I keep on saying it's important to take strong antioxidants on a regular basis to soak up those free radicals, so your tissues are healthier, your mitochondrial health will go up, your ATP will go up, the specialization of that cell and that tissue will perform better, and your body will be better off. That's why it improves your endocrine system, improves your immune system, it improves your neurons and your neural health. So please go to my store, the-studio-reykjavik.com, get the C60, soak up those free radicals so your different tissues perform better. That's the broadcast on the CCC. So please go to my store, the-studio-reykjavik.com, and also make sure you are following me on my channels. I have 4 channels on YouTube. I have Brighteon, Bitchute, and Rumble. Make sure that you follow me on all those channels. I also have a new channel on TikTok, so you can follow me there, and you can follow my feeds on X and on GETTR. All the links are in this video and all my videos. Thank you for listening, and have a nice day.